Assalamualaikum warahmatullahi wabarakatuh. In this video, I will proceed with the graph of the logarithmic function. So first, let's look at to this graph. So when the function fx is equivalent to the log x with the base a, and the base a is greater than 1, we will have increasing graph. Meaning that when the x is increasing, the y is also increasing. So for example, we have the function fx is equivalent to log x plus 3. So the base here is equivalent to 2. And then 3 log x minus 1 with the base 4. So the base here is equivalent to 4. So in general, the graph of the function of log x with the base a, and when a is greater than 1, we have 3 basic points here. So the first coordinate here, 1 over a negative 1, and we have the x-intercept for the graph of log with the values of 1. Therefore, the coordinate here is equivalent to 1, 0, and the next coordinate here we have a1. So let's say for this case, our a here is equivalent to 2. Therefore, the coordinate here will be 2, 1. The coordinate here is 1, 0, and the coordinate here is 1 over 2 negative 1. So this is the 3 basic point on the first graph, or on the basic graph of the log function with the base a greater than 1. And then let's look at to another graph. So when the base a is between 0 until 1, for example, here we have 5 log x with the base 1 over 3 plus 2. And the next one, we have log x plus 3 with the base 1 over 2. So here our base is 1 over 3. Here our base is 1 over 2. So when the base is between 0 until 1, we will have decreasing graph. Meaning that when the x is increasing, the y is decreasing. And we have also 3 basic points here. So for the first point here, we have 1 over a negative 1 as well. But since our a, let's say for this case, our a is 1 over 3. So a is equivalent to 1 over 3. So we will start with this coordinate 1 when you divide by 1 over 3 here. And then we have the coordinate of y is negative 1. So we will get the coordinate of x is 3 and the coordinate of y is negative 1. On the x-intercept, the coordinate is 1, 0. And the coordinate here in general a1. So when a is equivalent to 1 over 3, therefore the coordinate here is 1 over 3, 1. Okay, so let's look at to the properties of the function of log. So the function of log have a domain between 0 until infinity, and then the range is from negative infinity until infinity. Why the domain is from 0 until infinity? Because on the basic graph, we have a vertical asymptote originally at the line x is equivalent to 0. So this is the vertical asymptote, and this one also we have vertical asymptote on the line x is equivalent to 0. Therefore, the range is, we have to look at from bottom to the top. So from negative infinity until infinity with the x-intercept is equivalent to 1. So these properties is actually opposite with the properties of the exponential function that we have learned on the previous subtopic. So because the relationship between the function of exponent and the function of log, they are inverse to each other. So let's say the function of log is y is equivalent to log x with the base a. We can interchange this function in terms of exponential. So we will get x is equivalent to a power of y. So that's why on the graph of exponential, we have a horizontal asymptote, and on the graph of log function, we have a vertical asymptote on the line x is equivalent to 0. And let's look at to the comparison between the exponential and the logarithmic graph. So this is on the previous subtopic, we learned how to sketch the exponential growth. So we have the function of fx is equivalent to a power of x, where a is greater than 1. So the base a is greater than 1. So we will have the y-intercept on the values of 1. And when we reflect this graph on the line y is equivalent to x, so we will have this graph. Therefore, the coordinate of 0, 1 will become 1, 0. So we have the function of f inverse is equivalent to log x with the base a. So this graph is reflected. The graph of exponential function will reflect on the line y is equivalent to x. And this is the graph for the function of exponential function when the a is between 0 until 1. So we have this graph for the a power of x. And when we reflect this graph on the line y is equivalent to x, so we will get the function is equivalent to log x with the base a. So we will get this graph. So the red graph here show the reflection of the graph of exponential on the line y is equivalent to x. Therefore, the domain of the function f, which is the exponential function, negative infinity until infinity, will become the range of the exponential function or the range of the inverse function, and the range of the function f, which is 0 until infinity, will become the domain of the exponential function. Now let's look at today's example, transformation of the logarithmic function. Sketch the graph using transformation technique, show all steps and plot at least 2 points. So with the function fx is equivalent to log 3x minus 2 plus 1 with the base 1 over 3. So first what we have to do, we have to identify the basic function for this question. So what is the basic function? So the first graph refer to the basic graph. So we have to write down the function y is equivalent to log x with the base 1 over 3. So this is our basic function. And then the next one, we have to apply if there is any horizontal shifting. So we have minus 2 here, shows that the graph will shift to the right 2 units. So shift right 2 units. So the function will become y is equivalent to log x minus 2 with the base 1 over 3. Okay, the next one we have if there is any reflection or stretch or compress, so we need to apply that one first. So we have a factor 3 here. So this factor 3 shows that there will be horizontal. So it's either compress or stretch, depends on the values of c. So since our c is 3, which is bigger than 1, therefore there will be compressed horizontally. So this is the third graph, so which is horizontally compressed by factor of 1 over 3. So this is the transformation technique, and the function here is y is equivalent to log 3x minus 2 with the base 1 over 3. And then the next one, we have plus 1 at the back, shows that the graph will move up 1 unit. So we can write down the transformation technique here, shift up 1 unit. Therefore, the function is y is equivalent to log 3x minus 2 with the base 1 over 3 and plus 1. So let us try to sketch the graph here. So the basic graph, so since our base is between 0 until 1, so we will have decreasing graph. So this is our first graph with the base 1 over 3. So with the vertical asymptote originally at the line, x is equivalent to 0. So the coordinate here is referred to the x-intercept. So the coordinate here should be 1, 0. So let us choose another point. So I choose the point here. So since the point here should be 1 over a negative 1. So 1 divided by 1 over 3. So we will get 3. So 3 and negative 1. So this is the basic graph with the function y is equivalent to log x with the base 1 over 3. And then the second graph. So let's draw the second graph. So the graph will shift to the right 2 units. So when the graph shift to the right 2 units, we will have the new vertical asymptote. Originally, it is on the line x is equivalent to 0. So now our new vertical asymptote here will be x is equivalent to x is equivalent to 2. So this is the y-axis, this is the x-axis. So the new vertical asymptote, we have to draw the new vertical asymptote first. So x is equivalent to 2. Then we will have the graph on the right of that vertical asymptote with the new coordinate from 1, 0 will become 3, 0. And then the coordinate of 3, negative 1 will become 5, negative 1. So on the second graph here, the function is y is equivalent to log x minus 2 with the base 1 over 3. If you don't want to write down the function on the graph here, is also can, because you already write down the function on the transformation technique. So what important here is you have to put the numbers on each graph. So it will be tally with the transformation technique that you write down here. And then the third graph, so we will have the third graph, which is horizontally compressed by a factor of 1 over 3. So since it is horizontally compressed, so when it is horizontally, the changes is on the x. So meaning that our coordinate of our vertical asymptote here at the x is equivalent to 2. Also, you have to times with the 1 over 3. So since our vertical, since it is horizontally compressed by a factor of 1 over 3, so vertical asymptote you times with 1 over 3, so you will get the new vertical asymptote is equivalent to 2 over 3. And we will have the new graph here, and the new coordinate from 3, 0, you times with 1 over 3, so you will get the new coordinate will be 1, 0. And then the next one, coordinate of 5, negative 1. So we will get the coordinate of 5 over 3 and negative 1. And the last one, the graph will shift up 1 unit. Vertical asymptote, x is equivalent to 2 over 3. So this is our graph. So the new coordinate of 1, 0, we have 1, 1, and the coordinate of 5 over 3 negative 1 will become, so 5 over 3, 0. So this is our final graph. So what we have to do next is we have to determine domain and range. So for you to determine domain, what we have to do, there are two ways. So it's either you just look at to the argument of the question or of the final function, or you can just looking at to the graph, because we already have the graph. We have to look at from the left to the right. So the first values of x, so since we have vertical asymptote, therefore the domain of this function is equivalent to 2 over 3 open until infinity. So we cannot touch the line of 2 over 3, and the range of the function is equivalent to from negative infinity until infinity.